Hello students, welcome to the second year class of Computer Engineering and Information Technology for the data structure using C subject, and our subject code is 22317. We will see today's video's learning outcome. So today's video's learning outcomes are chapter number 5, trees and graphs. And in this video, we will going to learn about types of trees and tree traversal. So first, we have to just remind that what is tree. So a tree is a hierarchical data structure that naturally stores the information in a hierarchical fashion. The tree data structure is one of the most efficient and mature. The node connected by the edges are represented. Properties of tree. Every tree has a specific root node. Each tree node can be crossed by a root node. It is called the root, as the tree was the only root. Every child has only one parent, but the parent can have many children. Okay, means if we consider a normal tree, the tree has a root, branches, fruits, and all means flowers, all that things. Like this, every tree has a specific root node, and every tree has a single root node. Okay, and every child has only one parent, but parent can have many children. See here, these are the types of trees. General tree, binary search tree, AVL tree, red-black tree, and array tree. So in these types, we will see some types of these trees. First is the general tree. If no constraint is placed on the hierarchy of the tree, a tree is called a general tree. Every node, every node may have infinite number of children in a general tree. The tree is the superset of all the trees. Okay, this is the example of the tree. See here, this is root node A. It has three node B, C, D. Then again B has a E and F node. C has a G node, and G has again J and K node. D node, D has a H and I node. Means this tree is called as a general tree. Okay, because every node may have infinite number of children. Means there is no specific number of children like 2 or 1, like this. Now second is the binary tree. The binary tree is the kind of a tree in which most two children can be found for each parent. The kids are known as the left kid and the right kid. This is more popular than most other tree. When a certain constraint and characteristics are applied in a binary tree, a number of others such as AVL tree, BST tree, RBT tree, etc. are also used. When we move forward, we will explain all these types in details. See here, this is the binary tree. A is the root node, and these are two substrees, T1 and T2. Each node has a two. Each node has a two node. Means binary means two. Means as we know, binary numbers are only two numbers, 0 and 1. Like this, binary means two. Bi means two. A has the B and C node. B has the D and E node. C has the F and G node. Means two node or two nodes. Each and every node has a two node. Types of a binary. Degenerate, only one child. Complete, always two children. Balanced, mostly two children. Means in previous example, we have seen that tree is a balanced tree. Now see here, this is first type, that is degenerate, means only one child. Each node contains only one child, means first node, this node has only one node, then like this says, oh, each and every node has only a one child. And now this is a complete tree. Complete means always two children. First node has a two children. This node has a two children. Okay, means complete. We can sorry, this is balanced. Means this has a two children. This tree has a two children. Like this. This is the balance. Okay, now this is the complete. Means this one is every child. Every node has a two children. First node has a two. This second node has a, again two children. This third node has again two children. Now the skewed binary tree. It is the type of a binary tree in which all the nodes have only either one child or a no child. Types of skewed binary trees are there are two special types of a skewed binary tree. Left skewed binary tree. These are those skewed binary trees in which all the nodes are having left child or no child at all. It is the left side dominated tree. All the right children remains as a null. You see, in the left skewed binary tree, there are only a left side children and right skewed binary tree. These are those skewed binary trees in which all nodes are having right child or no child at all. It is a right side dominated tree. All the left and left children remain as a null. See here, this is the left skewed binary tree. Means this node has only a left node. This root node has only a left node, child node. And this is the right skewed binary tree. This is first, this is the right node. There is no left node for this node. So there is no left node for this node. And means it has a right node or no node. This tree has no node means it can be considered as right skewed binary tree. Now binary search tree. Binary search tree is a binary tree extension with several optional restrictions. The left child value of a node should be BST, be less than or equal to the parent value, and the right child value should always be greater than or equal to the parent's value. This binary search tree properties makes it ideal for such operations since we can accurately determine at each node whether the value is in the left or right subtree. This is why the search tree is named. See here, this is the binary search tree. Root node is 8. Means these values are less than root node and these values are greater than root node. Means left side values are the less than root node value and right side values are the greater than root node value. Means left subtree has value greater and sorry, right subtree has a greater value and left subtree has a less value from the root. We will see how to construct a binary search tree. Step 1, make the first element as a root node. Then step 2, for the next element, if value is greater than root value, go to the left. And if the value is less than the root value, go to the right. This is the simple algorithm for constructing a binary tree. So, see here again, if means we have to take first element as a root node, then second value. Now we will see the difference between the general tree and binary tree. So general tree, these are the uh, different points. These are the different points which is indicate that difference between the binary tree and the general tree. So first difference, a general tree is a data structure in which each node can have infinite number of children. A binary tree Binary tree is a data structure in which each node has almost two nodes, that is left and right. In general, tree root has in degree 0 and maximum out degree n. In binary tree, root has in degree 0 and maximum out degree 2. Means in generally tree, each node have a in degree 1 and maximum out degree n. In binary tree, each node have a in degree 1 and maximum out degree 2. Height of the general tree is length of the longest path from the root to the leaf of the height. Means maximum height of a child 1, then child 2, child up to n plus 1. And the height of the binary tree is height of the tree equal to maximum height and then left child, maximum height right child plus 1. Means subtree of a general tree are not ordered, but the subtree of a binary tree is ordered. Okay, see here, this is the example which has a different, which can distinguish the difference, above difference. See here, this is the general tree and this is the binary tree. This is the root of general tree, this is the root of binary tree. So in general tree, there may be a different, there may be number of nodes of one root, but in binary tree, each and every node, including root, has only two nodes. Means root has in degree 0 and out degree 2. But in this tree, in degree 0 and out degree means maximum out degree. It may be 3, 4, 5, whatever. Okay. Now binary tree traversal. Traversal means the visiting each and every nodes of a tree and may print their values too. Means traversing means nothing but the accessing each and every element or each and every node in the tree. So because all nodes are connected via edges, we always start from the root head node. That is, we cannot randomly access a node in a tree. There are three ways we use to traverse a tree: in order traversal, pre-order traversal, post-order traversal. Generally, we traverse a tree to search or locate a given atom or a key in the tree or to print all the values it contains. So first is the in-order traversal. In this traversal method of a left subtree is visited first, then the root and later the right subtree. Means this traversal are the basic concept of this traversal is as same as the expression tree because difference is that there are the operand and operator, but in this there is the root node left and the right. So in the expression infix means the operator is between the operands. Okay, means like this. Root is between the left subtree and the right subtree. Okay, this traversal method: left subtree, then root, then right. Okay. So we should always remember that every node may represent a subtree itself. If a binary tree is traversed in order, the output will produce sort keys values in an ascending order. Because in binary tree, the values of the left side are the less than root node and the values of the right side are the greater than root node value. That's why we will get the ascending order key values. Okay. See here, this is the example of the tree. This is the root, and this is the left subtree and the right subtree. So we start from A, and following the in order traversal, we move to the left subtree B, and B also in traverse order. Then the process goes until all the nodes are visited. The output of in order traversal of this tree will be first D, then B, means after this is the subtree, no? That's why we have to traverse left, root, right. So D, then B, then E, and after that there is a root A, and again we have to traverse the right side. That means that means A, F. This is again subtree. Then we have to traverse a left node, that is F, then root node C and G. Okay, so we will get D, B, E, A, F, C, G. Means we have to traverse like this. Means D, and again like this. Okay, means we can traverse it like this. Then we traverse it this root node, then this tree, and finally this G will get this G. Okay, algorithm. Until all nodes are traversed, step 1 recursively traverse a left subtree. Step 2 visit root node. Step 3 recursively traverse right subtree. Okay. Now the pre-order traversal. In this traversal method, the root node is visited first, then the left subtree, and finally the right subtree. Okay. Algorithm. Until all nodes are traversed, step 1 visit the root node, recursively traverse the left subtree, then recursively traverse the right subtree. Okay. We'll see one example. See here. In this example, we are going to start from A, and pre-order traversal. We have to first visit the A itself, then moves to the left subtree B, and B also traverse pre-order. And after that we have to go C, then C also travels by pre-order. Okay, the process goes until all the nodes are visited. The output is root node A, then again root node B, then left D, then right E, then for this subtree root C, left F and G. Okay, then we will get A, B, D, E, C, F, G. Now post order traversal. In this method, the root node is visited last, hence the name. Uh, First we traverse the left subtree, then the right subtree, and finally the root node. Algorithm. Until all nodes are traversed, step 1 recursively traverse the left subtree, then the right subtree, and third is the visit root node. This is the example. This is the root, this is subtree, this is another subtree. We have to start from A and following the post order traversal. So first we take the left, and then right, then root node. Okay. So first left is what D, then right is what E, and then root node B. Okay. Now again this is the root node, so ignore it. And after that, left subtree is F, then G and C, and finally the main root node is A. So we will get D, E, P, F, G, C, A. This is the post order traversal for the binary tree. CL, we will see one example. How a binary search tree for a given, draw a binary search tree for a given number. This is 50, 33, 44, 22. 77, 35, and 16, 14. As our algorithm told us, the first node is always root node. Means 50 is our root node, and second value is less than root node. Then this value will be placed as the um, left side. Okay, so we will construct it. See here, first is 0. So first is 50. Then we have to put it 50 as a root node. Then 33 is less than 50. That's why here is a 33. Then 44. 44 is less than 50, but greater than 33. That's why this root node. That's why it is in the right side. Then next value is 22. 22 is less than 50, but also less than 33. That's why it is in left side of this subtree. The next value is 77. Now 77 is greater than 50. That's why this is the right side value of the tree. Then 35, 70 is after the 77, and then 35. Then 35 is less than 50, and it is also less than 44. That's why it will be placed in the left side of this 44 root node. Then the 60 is greater than 50 and less than 77. That's why it is in the left side. And then 40 is less than 50. So in the right subtree, we have to put it last node is 35, and 35 is less than 40. That's why it is in the right side of the tree. Okay, this is the binary subtraction. Now this is another binary tree for the following elements: 30, 100, 90, 15, 2, 25, 36, 72, 78. This will be one by one. Means in exam, we have to follow this procedure itself. Okay, first our root node is 30. So 100. 100 is greater than 30. That's why it is in the right side. Then 90. 90 is greater than 30 and less than 100. That's why it is in the left side. Then again 15. 15 is the less than 30. That's why it is in the left side of the main root. Then 2. 2 is less than 15. Okay, that's why it will be put it here. Then 25. 25 is greater than 25 and less than 30. That's why it is a subtree of a right side. Then 36. 36 is greater than 30 and less than 90. So it will put it here. Then 72. 72 is less than 36. So it will be at the right side. Then 71. 70 is greater than 72. But 70 is in the right side. Then 10. 10 is less than 30. That's why in the left side and greater than it is greater than means not see here 10. 10 is less than 30. That's why that this side. But compared with this element, 10 is less than 15. So that's why it is in the left side. Again, we have to compare with the 2. So 10 is greater than 2. That's why it is in the left. It is in the right side of the tree. This last element is this right side of the tree. So we will get this binary tree finally. Is 30, 15, 2, 10, 25. Then 30, 100, 19, 36, 72, 70. Okay. Now binary tree, right in order, pre-order, and post-order types. So this is the binary tree. So in order means left, root, and the right. Okay. So first is our in order. We have Q, E, then F, R, then again R, F, R, then D, then H, then B, and then A. Okay. Now, for the right side traversal, I, J, K, then C, L, P. Okay, means we have to traverse the left side route, then right side. Then for the pre-order traversal, first root node, then left side, then right side. So root node is A, first element is A, then B, then D, E, then Q, then F and R. Okay. Now at the right side H, right side of the subtree is H, then C, then I, J, K, then L and P. It means L and P. Means left. First we have to traverse the left and then right. Then post order means left, right, and node, root node. So Q, R, F, E, then H, D, then B and K, J, I, uh, P, L, C, and finally root node is A. So this is the in order, pre-order and post-order traversal for this binary tree. So these are the MCQs. Which of the following is the name of the node having child nodes? Brother, sister, mother, parent. Answer is parent. What is the height of the root node of the tree? Answer is D. Height of the root node is 0 because root node is the first node of the tree. Now third is which node are the siblings of a node B of the given tree? See here in this tree. Which node are the siblings of a node B? Siblings of a node B. Okay. So E, C, F, both E and F. So answer is E and F. So siblings of a node B. So siblings of a node B are E and F. Okay. These are the types of trees and also the different traversal of a tree and the constructing of a binary tree. So, thank you.